Okay, so we're continuing on with 8.2, which is on area. We skipped one last time, right? Shh, guys, we skipped one last time. It was number 4. So we're going to go back and do that. So it says find the approximate area bounded by the graphs of y equals cosine of x and x squared. Use f in int, so math 9 on your calculator to complete your solution. All right, so first we need to kind of do a rough sketch. Cosine of x starts at 0, 1, and it comes down, goes back up. Okay. Symmetric. Okay, it's an even function, right? We've learned that word before, so we can fold it over the y-axis. All right, y equals x squared is also an even function, so we get that. Mine looks terrible, but it should look very symmetric. So it should cross in the same points, but with opposite x values. Okay, so Rachel asks, should you be able to integrate everything on your homework? A lot of them you won't be able to integrate. This is an example of one that, well, this one you would be able to, but some of them are kind of tricky. If they're polynomials, it should be very easy to integrate, but I told you guys you could use math 9. So we're going to go ahead and graph cosine of x in for y1 and x squared in for y2 and hit graph. So please do this with me. So get your calculator out. You might need to zoom in so you can see the points of intersection. Okay, let's find this point over here on the right side. Let's find this one first. So second trace, intersect. So go along the first curve to where you think the intersection point is. Go along the second curve to where you think it is, and guess. I just zoomed in. So I get 0.82413231. So dot dot dot, and then 0.67919. Dot dot dot. You guys get that? Okay, we know that when I do my area, I'm going to go from the two x values, right? So from the negative 0.824 dot 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 to 0.824. But when you are doing your AP exam, you cannot round. You can't do intermediate rounding. You can only round at the end. So what do I do next? Store, right? So I'm trying to find, you could find the other x value as well, but I told you it's symmetric, right? So it's going to be just the opposite of that. So I'm going to do second quit. I'm going to hit X on my main screen. And when I do that, 0.8241323, all that comes up. Okay, I'm going to store, so hit stow. Alpha A. So I'm going to store it as A. All right, and then you always write yourself a little note that you've stored that as A. So see, I wrote A and then circled it. So maybe I should be careful when I write A equals and say area equals. Okay, my values are going from the negative A value to A. And it's my top curve minus my bottom curve. So the top curve is cosine of x. My bottom curve is x squared. Okay, this one you would be able to integrate. Other ones are a little bit harder. Like if it was cosine squared, you'd have to do something else. Exactly. So if you guys were integrating this by hand, you wouldn't want to plug in A and then negative A and then subtract the values. So Mackenzie asked, can you do 2 times the integral from 0 to A of cosine of x minus x squared? And in this case, you can, because it's symmetric. So this right side that I'm drawing in red is exactly the same area as the left side in green. Okay, so I'm going to do math 9. I'm going to do my y1, so variables, y variables function y1, minus my y2, variables, y variables function y2. And my x values are going to go from 0 to alpha A. I'm going to take that answer and I'm going to multiply by 2. Okay, when you do that, you get 1.095. Okay, and that's your answer. All right, so let's skip to the next one. So number 6, so we did 5 last time. So let's do number 6. I got my answer to be 1.095. Okay, so number 6, same kind of thing. So find the area bounded by the graphs of y equals x squared and x equals 2 minus y squared by integrating with respect to y now. Okay, so when you integrate with respect to y, that means you're going to have a left curve minus the right curve. And all of these are going to be functions in terms of y. So you're only going to have y values. You're not going to have x equals. Okay, now let's think about if we had tried to do this one with top minus the bottom. Okay, if you try to do this one with the top curve minus the bottom curve, there's obviously something weird happening at 1, right? They're intersecting there. Okay, if you try to do top minus bottom, you would have top curve minus bottom curve, which would be kind of tricky. Do you guys see why that's hard? Because it's the same curve, right? So basically what you'd have to do is, this would be x equals y squared. You'd have to solve for y. So you'd get y equals plus or minus the square root of x. Okay, so the top curve would be square root of x. The bottom curve would be minus square root of x. Do you see how that works? So you could do this one with top minus bottom, but it'd be really hard. Okay, see how you would solve the other one for y? You'd have y equals, you don't have to write this down, we're not going to end up doing it this way, right? Y equals, you're going to do x minus 2, so, and then divide by a negative, so 2 minus x, and then the square root, and you'd have plus or minus. That's how you get the top and the bottom of this other side, so top minus bottom. Okay, and you'd already have 2 pieces. You'd already be breaking it into one integral plus another integral, and then top minus bottom. So do you guys see how that would be really, really complicated? Okay, we don't want to do that. We want to make it easier than that. So we're going to do right minus left. Okay, I will say that this one you could solve for y. Sometimes you can't. We don't know how to solve for y. So this is why we have to learn this right minus left method. You can't always solve for y. All right, so my right curve is the red curve. My left curve is the blue curve. Okay, can you guys tell which one's which? So x equals y squared and 2 minus y squared. Okay, the left is the x equals y squared. You can kind of do like a t-table to figure that out. But when you do a t-table, you're plugging in things for y. So if you plug in 0 for y, you get 0 for x. See how you have the point 0, 0. All right, so I don't know why I wrote left minus right. It's right minus left. Are you guys like, what? It's right minus left. All right. So your area is going to be right curve, so 2 minus y squared, minus left curve, y squared, dy. Now think about the things that we did with the x terms. So when we integrated with respect to x, our limits of integrations are a and b were x values, right? So you can go back and you can look at the last one we did. All right, we went from negative 0.824 to positive 0.824. Those were x values. So when you integrate with respect to y, you're going to go from y values. Okay, so do you guys see the area that we have is here? What's the lowest y value? What's the highest y value? Negative 1 to 1. And that's it. So you have negative 1 to 1, 2 minus 2y squared dy. Is there any symmetry in this one? Yeah. See how you could go from 0 to 1 and multiply by 2? So we're going from 0 to 1. All right, so I get 2y minus 2/3 y cubed. Yeah, I don't know why I put a 0. All right, so I have 2 out front, and then I'm going from 0 to 1. All right, so I have 2 on the outside. When I plug in 1, I get 2 minus 2/3. When I plug in 0, I get 0. That's why we did that, so it's easier. So I have 4 minus 4/3. So 12 over 3, so 8/3. So 8/3 is your answer. Okay, makes sense? All right, so 7, find the area enclosed by the line y equals x minus 1 and the parabola y squared equals 2x plus 6. Okay, so if you graph it out, let's say I want to put this on my calculator. I'm going to let my y1 be x minus 1. My y2 is going to be the square root of 2x plus 6. Is that it? Yeah, you need plus or minus, so y3 has to be negative square root of 2x plus 6. Okay, I'm just using my standard window. So I end up with something like this. Is that what you guys got? All right, so the area enclosed is going to be this red area. Okay, think about it. Do I want to use top minus bottom or right minus left? Right minus left. Do you guys see that you want to use right minus left? Think about if you use top minus bottom. If you did, you would have to separate this into top curve minus bottom curve for this part. And we don't want to have to do that. We would rather do right minus left. All right, so see how we have a definite right curve, a definite left curve. So we want to know what the y values that we're going from are. So we're going to do second trace intersect. This would be pretty easy to do by hand too, probably. You might have to arrow down to pop down to the second curve, or arrow up. So -1, -2. Are you guys having trouble? And 5, 4. Okay, if you were doing it by hand, you'd plug in the x minus 1 for the y, and then you'd square it so you'd have to FOIL it out. And then get everything on one side and factor, and you could solve that. All right, so our y values, remember, is what we're going from. So that was the part I always messed up on when I was in school. So I always would think, oh, x values, x values. So if you're integrating with respect to y, use y values. So you're going from -2 to 4. The right curve is, x minus 1, is that what I write? It has to be all y values. So you need to solve for x. So it's going to be y plus 1 equals x. And this other one, when I solve for x, I'd have y squared minus 6, all over 2. In other words, 1/2 y squared minus 3 equals x. So you always have to have your equations in terms of y. So solve for x, yeah.
So do you always have your equations in terms of y when you're doing it from right to left?
Yep. So you always do, when you're doing right to left, you always use y's.
Why would it be -3? Because like that's where it crosses the very tip of the x-axis.
Okay, so if you're doing the right minus the left, you have to have like a right curve and a left curve enclosing it, which we have. Do you see how we have a right curve and a left curve? All right, and then the y values have to go from the lowest y value of that enclosure to the highest y value of that enclosure. Okay. Okay, you could break it up, like you were saying, from here. That would be from -2 to 0. You could do that. And then from 0 to 4, but it'd end up being the same thing. Do you see that, Mackenzie? Because you'd still have right minus left. It'd be the same curves anyway. So you'd go from -2 to 0 of something plus 0 to 4 of the same thing. So you could just combine them into one. Okay. So right curve is y plus 1 minus left curve 1/2 y squared minus 3 dy. So I'm going to have a -1/2 y squared plus y. Then I have 1 plus 3, so plus 4 dy. So -1/6 y cubed plus 1/2 y squared plus 4y, going from -2 to 4. I ended up putting this in for my table, like in for another y1 with x values, and then I just put it in to find 4 and -2, since I knew how to do it twice anyway, but you can do it whatever way. So I got 13 1/3 minus a -4 2/3. 18 total. Yeah. Okay, so the question is, what would we need to do if integrating with respect to x? Draw a sketch. So if you were integrating with respect to x, we kind of already talked about that, but let's go ahead and draw the sketch. You don't want to draw the sketch, is that what you said? See how art can be helpful in calculus, being able to draw these things. All right, so if we were doing top minus the bottom, so you need to think about where a top curve and a bottom curve would meet from between what x values. So do you see you'd have to draw like a straight line right here? Let me not draw in the same color. So you'd have your top. That would be y equals the square root of 2x plus 6. The bottom would be y equals negative the square root of 2x plus 6. All right, and then do you see on the other side of the green line what the top and the bottom are? So the top would still be that y equals the square root of 2x plus 6, but now the bottom changes. The bottom changes to y equals x minus 1. So you basically have two integrals that you would add together. Okay, what x values would they go from? You'd have to find it, right? So you found -1 to -2 was this point here. So it'd be from wherever it's crossing the axis, which Mackenzie was saying earlier, it's -3. Did you guys see how she got that? It's what would make your square root equal to 0. So you go from -3 to -1 for the first integral. And then for the last one, you'd go from 1 to 5. That's what it was before, the x value, 5, 4. Yeah?
I'm so confused on how we know what to subtract from what, which curve.
It's always, you're either doing top minus bottom or right minus left. So in this case, if we're integrating with respect to x, it's top minus bottom. If you're integrating with respect to y, it's right minus left. Do you see what I'm saying?
How did you know which square root to use?
Like to use the positive square root or the negative square root. So Rachel asked, how do you know if it's positive square root or negative square root? Okay, the y values are positive over here. The y values are negative down below.
Isn't it negative?
Yeah, it's negative.
It's negative what?
-1. -1 and
Oh yeah, -1, yes. To -1, yeah. What do you want my negative? Okay, next up. All All right, so the birth rate of a population is B of t equals 2,200 plus 52.3 t plus 0.074 t squared people per year, and the death rate is 1460 plus 28.8 t people per year. Find the area between these curves. What does the area represent? Okay, this is a typical AP type free response question, right? Okay, so let's go ahead and graph both. What might be difficult about this is finding a window. Okay, you can always try Zoom Fit, which is Zoom 0. Sometimes it works, sometimes it doesn't.
Hello.
Hi. Mine's not giving me the greatest area, or the greatest picture, but it looks something like this one's going up, because that's our parabola. This one's a line, so something like that. Did you guys see that? Did you try Zoom Fit?
What's the window?
I tried Zoom Fit. My window ended up being like Y min is 1100, Y max is 3000, somewhere around there. Yeah, Zoom Fit's not always the best one. Okay, think about it though logically. If you look at B of t, can you guys see what that y-intercept is? Like if you plug in 0 for t, what do you get? 2200. So you should probably make your window at least 2200. So make your y's go up to 3000. All right, we're going from 0 to 10. So my area, I'm going to have my top minus my bottom, so I'm going to have B of t minus D of t. So remember on your AP exam, write the simplest form. And the x values, or the t values, go from 0 to 10. So I'm going to do math 9. I have my y variable, so y1 minus y2. And your x's are going from 0 to 10, so your t values, I guess. I got that number. So 8,821.667. You guys get that? Okay, so what does this area represent? So is it people? Is that our units? Okay, and what's the 0 for 0 to 10 mean? Okay, so over 10 years, what's happened? Yeah, your population has grown by that many people in over that 10 years. So population has grown by, we'll round down. I don't know about 2/3 of a person. So we'll say 8,821 people over the 10-year period. Okay. On your AP exam, you can round up or round down. It doesn't matter. All right, so are you feeling okay about these? Do you want to try more examples?
Well, there's one of the books that says, you said that we had split it into 2. I didn't know how.
Okay, which one was it? Okay, Catherine wants to look at number 9 in your book. They'll thank you later, I'm sure.
Yeah, you had that first one done on your homework.
Guys, you don't have to talk while I'm drawing this. I've heard that those that watch this video can hear all of your conversations, so if that makes you feel any better, I should go back and listen to it sometime. All right. Okay, so if we're doing top minus the bottom, so top minus the bottom, are there ever, like, from a certain x values, is there a definite, like, top and bottom curve?
For certain x values.
Yes, for certain x values, right? So from here to here, do you guys see it? There's a definite top and bottom. So this is the red. Okay, so what point is that right there that I just drew in? 1 is for the y. Is it 1 for? Yep, 1 for x. So it's 1, 1. So you're looking at the y equals 1 intersecting with y equals x. All right, so that's 1, 1. So that area that I've drawn in red would be from 0, right? That's 0, 0. So x is 0 to y is, or from x equals 0 to x equals 1 of the top curve, so x, minus the bottom curve. So the bottom curve is the x squared over 4. Okay, now for the blue area. Top curve minus bottom curve. Do you guys see it? Yeah. So for the blue one, we're going from 1 to, what's this point of intersection? 1 is for y, right? Because it's on the line y equals 1. What's the x? Nope. 2. Do you guys see? You could solve it if you need to. 1 equals x squared over 4. So 4 equals x squared equals plus or minus 2. It would have to be x equals positive 2. All right, so you're going from 1 to 2. Your top curve is 1. Your bottom curve is x squared over 4 dx. And that's what you integrate. So we'll go ahead and use Math 9. So I said you could use that in your homework. All right, so I'm going to have x minus x squared over 4, comma x 0, comma 1. So the first part's 5/12. Okay, and then do it again. You can do second enter a couple times if you guys want to pull up the last thing you had. Sometimes that helps. I got another 5/12. Did you guys get that? So you get 10 over 12 or 5/6. Okay, so that's your answer. Okay, so the remainder of the time, I guess you guys can work on your homework. I'll come around and answer questions.
Can I get my